Any comments or questions? If not, we will move on to our next presenter, Richard Steenbergen. And he's going to tell us what's wrong with the Internet Routing Registry and why it's all... what? Routing. Routing like program with two M's and an E in it. Surely. These damn Brits will be gone soon. It's okay. Control L.
So, yes, it's another IRR presentation. Every time I've gone to an analog in recent years, there's always one. And every time somebody gets up and says, nobody uses IRR, it's worthless, we don't like it, we don't use it, we can't maintain it. Somebody says, everyone uses IRR, you're crazy, why aren't you doing this? Somebody tells you you're a horrible person, you're polluting the internet, you're destroying the internet, you're allowing people to leak prefixes everywhere if you're not using IRR. And some people say that IRR is inherently broken, full of garbage, and that's life. So I had this conversation with a lot of people, and there's a lot of common knowledge about this, or what should be common knowledge, where everyone says, oh yeah, I know it's full of garbage data. But a lot of people never got around to quantifying this. How full of garbage data is it? Is it really full of garbage data? Is it perfectly valid? Is it not? So I wanted to actually quantify this with some statistics. So for anyone that's been living under a rock, IRR is the Internet Routing Registry. It's a distributed database where networks can define their routing policies, which for our purposes as pragmatic network operators basically means you define a list of prefixes that you're going to accept or announce. In the case of a transit customer, you define your prefixes and then you define your customers behind you so that someone 5 hops away can look at this and have a realistic expectation of what prefixes you're going to be announcing and filter the ones that you aren't. So, kind of the theory behind what's wrong with the data is that it's distributed databases. There's no central authority. There's nothing preventing you from registering routes that are not yours. There's nothing preventing you from pretending to be someone else. And there's nothing preventing you from duplicating the data. And in fact, what tends to happen is not so much malicious attacks as it's a very complicated system. So people register a prefix or register an autonum or an AS set in a routing registry somewhere, and then they don't maintain it. Or they register it with a transit provider, and then they change transit providers, and they never go clear out the old data. Or a company goes defunct, and records never get removed. So I wanted to do actual analysis. So here are some basic statistics on which IRR databases people are actually using. This is a count of route objects, which is IPv4 routes, by the database that originates them. And basically the way that the database mirroring works is everyone mirrors everyone. It's an IBGP type relationship. So if you run a database and you don't go out and actively look for and mirror every database that's out there, you're not going to have a complete view. So you see there's more than 225,000 in RADB. That's by far the most popular. Strangely enough, it's also the one that charges the most. So I was surprised by that. I was surprised that more people weren't using free resources. Obviously, a distant second is ripe. And then you get into a lot of provider-run databases like Level 3, Savvis, NTT. You come down to AppNic. Bell has one, Reach has one, Aaron has one, and then you get into Epic. Has been bought out many times. AltDB is a public free database that a lot of people use, but there's no support behind it. So anyone that doesn't understand IRR doesn't really end up using this because they can't figure it out. And then you end up with a whole collection of others. And literally there's another 10 that I have classified under others, and if you group them all together, it's not even as much as the smallest other provider, other database. Here's a distribution of again, I'm looking at route objects Actually, no, I'm not. No, this is all objects. This is a distribution by their change date. So you can kind of get an idea how many of these things are records that have been updated recently, how many of them are many years old, or in some cases many, many years old. And there's actually a fair number of these. Here's a count of how many have duplicate objects. So this is route objects again. So you see there's 265,000 route objects that are unique. And there's more than half have some level of duplicates. And you can see that there's almost 80,000 that have 2 duplicates, going all the way up. And there's actually a whole pile. I think the biggest was 53 duplicates. Yes, someone actually registered from 53 different origin ASs the same route. And here's some analysis of kind of the distribution of prefix lengths, what you see out there. There's a lot of people that are registering everything under the sun, including things that are never going to get propagated. There's a bunch of 32s floating around. Strangely, no one's actually registered anything longer than a /8, which I found surprising because I figured someone would do something. And this is a slide for pure comedy value. When I sorted the route list, this was the very first entry, and I kind of figured it was all going to go downhill from there. When I saw that someone proxy registered 0.000/8. And a lot of what tends to happen with this is there's networks. For example, this is proxy registered by BTN. BTN doesn't use IRR to filter their customers, but they have transit providers that do. So they find themselves in the position of saying, we need to publish this data or else no one's going to accept our prefixes. So they tend to proxy register everything that they come across, whether it's valid or not, whether it exists or not. So I wanted to also do some analysis of the accuracy by individual networks. Because a lot of people that I talked to said, oh yeah, those other people, they don't maintain their data, but we do, we're good, we're good. So basically the questions that I wanted to ask are, how effective are the filters today? If you were to try to filter another transit network today, or a peer, or whatever the case may be, how many valid routes would get through? How many would be rejected? And how many would be allowed through even though they're not valid or not used? And how much does that expose you? So if you think that you're filtering something, but in reality your filters allow everything, then you're not really protected. And some of these questions I didn't have time to answer fully in the presentation, but something to think about. How easy is it for malicious registration to occur? How easy is it for some of these objects to be proxy registered under some maintainer that you have no control over, that you have no association with, and someone's just decided to register that route? And even if it's under your object, even if you try to maintain your database, it may not be maintained. So what I did was I compared actual announcements that different providers are making against their IRR object. So the data was queried from RADB. RADB just happens to be the de facto source for querying because they make the most effort to go out there and maintain mirror relationships with the most other IRR databases. You can query others, but they're only going to hit a fraction, so you might miss some things. So in reality, as I showed, most of the data is actually coming from RDB anyways. And I also assumed the best possible case. I assumed more specific prefix matching, which means if someone registers a 19 and they announce 2 20s, I consider them valid. If you turn off that, it changes the results, but I want it to be as fair as possible. So what I ended up doing here, there was a concern that a bunch of people were going to be upset if I picked on anyone's network. So I decided the easiest way to solve that problem would be to pick on everyone's network. This is purely in alphabetical order. A's first. So just to explain the fields here, I show the IRR object that was queried. I show the total number of routes that object expands to. So in this case, you see that AboveNet expands to 174,000 routes. Then I compared these guys show the number of routes that they actually announced to customers. These were taken from live peering feeds as real snapshots within the past week, so they're as accurate as I can get them. You see that AboveNet announces 8,397 routes, which is their customers. If you run their announcements against their IRR object, you see that 4,100 of them are accepted and almost 4,300 of them are rejected, which you see lower down. You have a false reject rate of 51%, which I consider bad. Going back up, you see what I classify as unused. Of the 174,000 routes, 170,000 of them were not touched, and I actually count the number of hits to the routing table. So if someone has if someone has an aggregate and then it gets matched by some more specific, I'm actually counting whether that route object was used to approve a prefix or whether it was not. So you see 170,000 routes were not used at all in allowing any prefix. More interesting, I think, is the next one, which is 106,000 routes were not anywhere in the global routing table today at all. So it makes you wonder what those are. Later we have autonums that are referenced and missing. Basically what that is, when you query an IRR object that's something recursive like an AS set, it will eventually expand to a list of autonoms. As soon as you go all the way down to the very bottom, you're just going to have a list of autonomous systems that have routes associated with them. So what I say here is when you fully expand their AS set, there are 231 autonomous systems that are referenced but not defined. And basically what that means is that anyone can come along, register one of those autonomous systems, start announcing routes, and it will be picked up in this AS object, which is obviously a security hole. False reject rate I explained, false acceptance rate, I just kind of wanted to put into perspective how much more someone is potentially allowing than what they should be or what they're actually actively announcing. And obviously there's going to be some amount of overlap for this because there are a lot of networks that have multi-home customers where a customer is not currently announcing something. But within reason. So this is just essentially the 174,000 divided by the 8,000. But it gives you an idea that AboveNet is, in their object, has 20 times more routes than they're actually using. And the notes here, the autonum records, the export records here, and the actual documentation that you find online, PeeringDB and other places, actually claims that this is AS-above. But it turns out that doesn't actually exist. The only thing that does exist is AS-MFNX. So I grade this an F based on failing 51% of the legitimate prefixes and allowing 170,000 unused routes through. British Telecom, and basically what I did was I tried to pick I went through every tier 1 that I could find, and then I went through every major tier 2 that in theory does hundreds of gigabits. So British Telecom was another example. Here you see that they register 55,000 routes. They actually only need 4,000. But they have a decent acceptance rate. There's only 2.8% that are being rejected. Overall, it's not that bad, so I give them a C-. Cable and Wireless registers 266,000 routes. They only need 16,000. So they have a very good acceptance rate. They're not falsely rejecting a lot. They're only rejecting 1.6%, which in the grand scheme of things, there's worse. But they're allowing everything that you can possibly allow almost through, and that defeats the purpose of the filter. Not only that, but they have such a very deep recursive AS set that it took me over 2 hours to pull it, and this was under the best possible polling conditions where you have recursive server-side expansion, so there's no back and forth to expand everything as you see when you query the RIPE database. When you query RADB, you can actually do a recursive server-side expansion. So, and this was also queried 5 milliseconds away on a gig-connected host. So you can't get any better query conditions, and it still takes over 2 hours to run. So just to give people an idea of how scalable these filters actually are. And I give them a D just because of the vast number of false things that are allowed. Deutsche Telekom, similar type of scenario. Their object expands to 178,000 when they only need 13,000. So they only have a 5.7% rejection rate, which, you know, if you're one of those 5.7% of customers, you're probably not going to be happy the day that someone's filtering you. So, you know, even when it's something that low, it's something to keep in mind. But again, a massive number of objects. I'm missing the number of things that are not even found in the global routing table. But again, you see a massive number of things that shouldn't be allowed. France Telecom, same kind of scenario. They are actually not allowing 34% of their announced prefixes. They're actually not including that in their object. So even though they don't have a massive number of false acceptance, they have a very high number of false reject. So I end up categorizing that as a fail. Global crossing is an interesting one. They not only fail, but they fail at failing. They don't even configure the AS set correctly. There's no reference to any other customer AS sets, so this very clearly will not work because it's not even configured correctly to begin with. So you see that they falsely reject 73% of their customers, which, if you're one of their customers and someone decides to filter you, probably not a good day. Hurricane Electric, I threw them in. They're one of the better ones. 36,000 routes registered, 7,000 that are actually announced, and they're only rejecting 3.9%, not bad, and they're only falsely advertising or falsely accepting 5 times more than their actual routes. So it's C- territory. Level 3, this one's different because they're not actually using an AS set. They're using what's called a route set. So an AS set is when you define your customer AS sets or altnums, and then that gets dynamically expanded. A route set is when you just define a list of routes. So the advantage is there's no query time. It doesn't take hours to expand the set, but it also doesn't update. So if one of your customers changes something, it doesn't automatically propagate. Level 3 would have to rerun this. So in this case, you see that they're missing a large number of prefixes. And I actually talked to some of the level 3 guys about this, and basically what they said was the server that runs the IRR updates had CPU problems and it hasn't run in a few months, and they're sorry and they'll fix it. Fair enough. But they fail because they reject 30% of their customer prefixes. I threw my own company in because everyone that I showed this to said that if I didn't, they were going to come to the microphone and heckle me. And I give myself a B+. It's not it's not perfect. Actually, what I was surprised, because we do not proxy register anything for any customer. We do not do manual updates for any customer, and we require every customer to be in IRR. And even then, we had 6 goofs. And the goofs actually turned out to be one router was not correctly updating. It was not correctly updating removes. So in 6 cases out of 1,200 prefixes, someone actually removed the route object and continued to announce it, and we just never stopped blocking them. So had we been correctly blocking them, they might have gotten pissed off and re-registered it, whatever the case may be. But 0.49% rejection, I think we're one of the best. And some of that just because of the type of customers we have, we can really enforce that. I really pity a lot of larger networks that have customers that are not as clueful, having to explain what IRR is and get data registered correctly. So NTT America expands to 289,000 routes, which is clearly more than the global routing table. If you look at the number of rejections, it's very low. They're only rejecting 21 prefixes. But again, they're allowing 240,000 prefixes through. And 166,000 of those do not exist anywhere in the global routing table. So Savvis, similar type of situation to every other Tier 1 or Tier 1 type provider. 100,000 routes registered, 48,000 are actually announced. And only 21,000 make it through. The other 27,000 not included. So 56% failure rate. That's bad. They get enough. Tiscali, major European carrier, 61,000 routes in their expanded object, 28,000 that they're announcing to peers, only 13,000 make it through. Again, more than 50% failure rate. So also an F. Telecom Italia, major European provider. And a lot of what people told me was that, oh, check the Europeans because they're very good on maintaining their IRR data. Americans, they're slack asses. You know, they're not going to maintain it. But those Europeans, all this data is going to be accurate. And what I found is that it's not true. Again, 165,000 routes and a 30% failure rate, and 10 times more routes being allowed through that are not being used. Telia Sonera, similar type of thing to everyone else. Basically, everyone seems to fall into two categories. Either they massively over-allow in order to get their acceptance rate high, or they don't, and then their acceptance rate is really bad. So this is an example of one where they massively over-allow. Tata, VSNL, Teleglobe, etc. This was actually the longest one that I had to expand. I gave up waiting after 4 hours. I let it run overnight. There's a lot of recursive, and literally, I'm not even going all the way down into the AS set and dealing with levels of recursion. There's just a lot of references. You see, there's 926 defined autonomous systems that don't exist. So, when they get a customer, they add them, but when they lose a customer, no one ever seems to take it out. So same type of scenario, massively over-allowing. Quest, exact same scenario as Global Crossing. They're not properly configuring their AS set, just not even attempted to configure correctly, and so they're rejecting 35% of their prefixes. WV Fiber, through them, and also 41,000 route objects, 2,700 announced. They're rejecting 16%, which obviously, as you've seen, there's been a lot more people that have been a lot worse. So here's an interesting one. What I did was I took every route object out of every IRR database and considered that to be a single object, call it AS-all. And then I projected the global routing table that I saw against that, just to see what the total rejection rate is. So there's 372,000 routes registered in every IRR database. 184,000 of them are valid. Again, this is with longest prefix matching enabled. And 81,000 of them completely fail. So there's 81,000 routes in the global routing table that exist nowhere in IRR with no covering route. And 235,000 of them fail. So again, false rejection rate of 30%. So here's kind of the summary. Here's the tier 1-ish, and I'm not going to get into debate as to who's paying settlement, but starting with what used to be a list of tier 1s, you can see that most of them either fail miserably, fail almost miserably, or just don't even try to maintain any IRR data at all. And then the tier 2s, it gets a little bit better. The smaller networks tend to be a bit better because it's easier to maintain.
Hey, Richard?
Yes.
Jared Mach, NTT America. On one of the previous slides, didn't we have a C and now we have a D on this one?
Did I not update you? Oh. I'll go lower that to a D later on.
Thank you.
But again, you see that most people tend to fail. And the people that I showed this to, there were a lot of smaller sized networks that I showed this to and ran their announcements against. And a lot of people that thought they were really good turned out not to be. So here's the upside. I'm actually releasing the software that I use to do this analysis. I have a package called IRR Power Tools, which is designed to allow ISPs to filter their customers. I've given a presentation about it at ANOG in the past. There's links to it. It's open source code. It's in PHP. I'm sorry, you'll have to compile PHP. Deal with it. But actually, I was going to have this code finished and uploaded, but there were a couple last-minute tweaks that I wanted to put in. So the new version will be 1.3, and it'll be uploaded probably by the time I get home. So give it a few days before you start sending me complaints. And speaking of complaints, here's where you send them if I made fun of your network. send me all the hate mail you'd like. Questions?
Doug Montgomery NIST, is your false acceptance rate based upon one point of observation, or are you looking from multiple points of the BGP table?
Do you mean, am I looking at every possible prefix that they're announcing, or am I only looking at best path?
Well, why don't you?
Where are you getting the feeds?
Where am I getting my feeds for what? For
So there may be a route object that describes an origination that's visible in some part of the net somewhere. Yeah.
Yes.
So are you doing multiple? Are you looking at as many places as possible, or one place?
when I look at an individual network, I've literally got an adjacent rib in from a peer, so I'm considering everything that they announce. When I'm looking at the global routing table, I'm looking at my global routing table. So yes, it's possible that someone has set some no export somewhere, and obviously some people carry more prefixes than me. I run a decently peered network and have a lot of views, and I consider this to be a pretty common global routing table. So yeah, there could be a few that show up and do not exist anywhere on the internet, that only exist in a certain portion of the internet that I'm not seeing. But I really didn't have time to compare against everyone's transit view to see if those are missing. And it's only a few thousand routes in any case.
Hi, Guy from Limelight. So if you took off the longest, the prefix matching,
Mm-hmm.
did you actually run that and see what does that change the percentage to?
I ran that on a few, and basically it changes by around 25% on most of these networks. So yeah, there are a large number of more specifics out there that are not registered in any IRR object. Jared?
Hi, Jared Mach, NTT America again. So one of the things in looking at our number, you showed us having about 290,000 objects.
Yes.
I'm wondering, so you said, did you go out and expand? Because we've had some customers in some regions of the world decide that they have a 16 and they want to, for hijack protection, they register every combination underneath that 16, so every 17, every 18, 19, down to 24, which has been relatively painful for us in some of our tools. Did you actually roll all those up into one, or does this reflect perhaps some of our customers' lack of patience with us in updating filters in a timely manner?
Actually, I didn't. That was one of the limitations. You have no idea how difficult it is to do longest prefix match in PHP. Just tell you. Yeah, that was one of the limitations. Was when literally what it does is it does a longest prefix match. It increments a reference counter, and then it goes through and scans the table and says how many of these were hit. So if, for example, someone registers a 16 and then announces two 17s, the 16 is going to show up as unused, even though it was kind of sort of used. That's a limitation of the software, but I don't think that was a significant contributor to the overall failure rates or the overall false acceptance rates.
I think go to the far left mic. I think he was next. And I'm going to close the mics after these few people that have stood up. Okay?
Jay Hennigan, Impulse Internet Services. We're a regional ISP that has probably, like many regional ISPs, grown by acquisition of other smaller regional ISPs. And you are correct that the database has a lot of old cruft in it, including some route objects from us, which were put in there by a long since ex-employee that are maintained by a long since ex-carrier. So being a good netizen, is there any mechanism that anyone here can suggest to get rid of those things? Because when dealing with the IRRs, it's basically send email and authenticate yourself, and you'll get email back that basically says it failed. And human beings that are in a case to contact are relatively rare, and with hijacking going on, they are likely to rightly ignore you anyway.
Yeah, that's actually one of the things that I meant to cover and I forgot. I did some simple tests to try to identify how many things were proxy registered or registered by someone that was not the origin AS. And there's more analysis that can be done on this, but just grepping for the word proxy, there were 92,000 hits of the 373,000 route objects. Just as an example, last night I was running this by some people, and I had someone give me a prefix of an ISP that they ran in 98, and there were 5 proxy registrations from different networks that they had in some way been associated with, who proxy registered it completely unnecessarily. The original route was there, correct, and predated everything, but it got proxy registered anyways. And of the 5 duplicates, none of them had the word proxy in it. So if that's an indication of how difficult it is to find these things and track them down. I've actually seen the same problem on our prefixes, where people that we have no association with decide that they need to proxy register everything that they see in the global routing table. I haven't actually had any luck with contacting the individual IRRs, like I said, because it's so distributed, it's difficult to do. But I've had a bit of luck with the companies that are still in business, emailing them and say, hey, how about you remove that? And a lot of times they tend to be responsive.
Jason Schiller, UUNet, Verizon Business. I just wanted to point out that the slides on the web seem to be an outdated version of this talk. And
I want to point out that the outdated.
thank you very much.
Problem solved.
Andrei Rubachevsky, Ripon CC. So what's the conclusion of this talk? Because if the false rejection rate is higher than 0, either this is a momentarily problem that is being fixed, or the IRR is not used for filtering, for building filters.
I mean, basically the point that I wanted to make is right now it's not useful for building filters, and people that think it are, I wanted to give them a reality check. This is the current state of the routing database. And really to kind of make the point that what we're facing isn't so much a technical problem as it is a documentation and user problem. We've designed a language that is so complicated that allows you to specify so much that it's so difficult for people. I mean, how difficult is this concept to grasp? It's a list of prefixes and then a reference to other people's lists of prefixes. How could we design something that is so complicated that a huge number of our customers come to us and say, we can't figure this out? And I think that's the problem.
Right, thank you. So this basically says that people use this for documentation purposes rather than for filter building purposes.
Well,
because they're populating this IRR, right?
What I've seen is that people have a lot more success using it for filter building of their customers and not so much for their peers. And the bigger your network gets, the further you're removed. I mean, I'm not holding some of these individual networks responsible for having bad data, but their customers do. And it's very difficult for them to go maintain all of their customers' data. So by the time you get up to a tier 1, you are so many levels removed from someone who's responsible for maintaining that data, it's going to be invalid.
All right, and just one tiny comment, I missed this. What kind of BGP data, source of BGP data you're using?
For the direct, for what I was considering someone was announcing, I literally went out to individual networks that peered with individual networks or through looking glasses and obtained the full table, what people were announcing to other networks as their customers. So what it legitimately should be filtering against.
I think you may want to use RIS data. It's more comprehensive. It actually contains 16 collectors. So
well, it doesn't. It doesn't, because the problem is you're not seeing only seeing the best path. The only way BGP doesn't propagate any more than the best path. So as soon as you have any decision-making algorithm in there, you're starting to lose duplicates. The only way to see an entire view is to go straight to the source and see exactly what they're advertising.
Randy Bush, IIJ. To answer your question, Ras, which was how could we design a language that was so complex that it was unusable and poorly used, is we design it by committee, boiling the ocean and putting in every feature we can. And we have a place to do this. It's called the IETF. And we're still doing it there today. So the reason I do this is not to be nasty, though of course I have a reputation for it, but to try to point out that maybe we shouldn't be doing this today with the other places in the IETF where we are tempted to fall into the exact same traps. Don't boil the ocean, don't try to be complete. All we needed here was a list of damn prefixes the AS could announce. And we garbaged it up so bad, it's unbelievable.
And I think with that, thanks very much, Raz.